So this one will bring us to calculating molar mass of a substance. So when we say mole of a substance, what is a mole? A mole is just a unit of measurement, and it is the amount of substance that contains 6.02 times 10 to the power of 23 entities. When I say entities, you can just see it as particles of that substance. What I mean is that if you take 1 mole of a substance, 1 mole of any substance, and you try to count the particles in that substance, that particles can be atoms, those particles, they can be molecules or they can be ions. In fact, they can be electrons as well. So if you take 1 mole of a substance and you try to count the number of particles in that substance, that is the amount you are going to get. And that is what we call Avogadro's number. That is determined by this scientist that is called Avogadro. That is why it is named after him. So for example, if you have 1 cup of water and you're able to count the molecules of water in that 1 cup, for example, this is a cup here, and then I have molecules of water inside this cup. So if this 1 cup is 1 mole, and I try my best to count each molecules of water in this 1 mole of the cup, I'm going to get 6.02 times 10 to the power of 23 water molecules. So that is the relationship between mole of a substance and the number of particles of that 1 mole of the substance. And that is what we call Avogadro's number. So when we say molar mass is the mass of 1 mole. So if you take this now, if you take this 1 mole and you try to weigh it, the value you get is the molar mass of that substance. So please don't forget, molar mass is the mass of 1 mole of a substance. So we've talked about the Avogadro's number, the mole, and the mass of 1 mole. The unit of a mole is grams per mole. So let's see how we can use this in calculation. So difference between atomic mass, molecular mass, and molar mass. So they may ask you to differentiate between all the 3, or you may get to a point that you want to know the difference between atomic mass, molecular mass, and molar mass. Of course, we've met all the 3 of them today. The atomic mass and the molecular mass are expressed in atomic mass unit. That's it. But molar mass is expressed in what? In grams per mole. So that is just it. All of them, they will have the same value, but the unit will be different. For example, the atomic mass of sulfur is 32 atomic mass units, and the molar mass of sulfur is 32 grams per mole. You can see that unit is just different. For water, because water is a molecule, the molecular mass of water is 18 atomic mass units, and the molar mass of water is 18 grams per mole. So the difference is just the unit. So let's go ahead with calculating number of moles, which is also very easy. We just need this relationship. N means number of moles, and this M is the mass, and then capital letter M is the molar mass. Of course, we said it is a mole. So this is the relationship between 3 of them. Of course, we know this from our secondary school days. So let's do this in calculation. Calculate the number of moles of calcium carbonate in a stick of chalk that contains 14 grams of calcium carbonate. So we are calculating number of moles, and then we know that number of mole equals mass in grams over molar mass. Molar mass means mass of 1 mole. So we have mass, which is 14 grams, and then we have molar mass of calcium, which is 40 grams per mole. And then we should be able to calculate the mole of calcium that way. So what is the mole of calcium? Yes, the mole of calcium is going to be 14 divided by, sorry, it's not calcium only, sorry. We are calculating calcium carbonate. Okay, so we need to get the molar mass of calcium carbonate first, because it's not 40, it's supposed to be molar mass of calcium carbonate. So I'm using molar mass of calcium only. So let's bring it down here so we'll be able to finish the calculation very well. So for calcium, we said calcium is 40, and then we have carbon, which is 12, and then we have oxygen, 3 atoms of oxygen, so it's going to be 3 times 16. I'm trying to calculate the molar mass of calcium carbonate there, CaCO3. We did that before, how to calculate molar mass. So if you do that, we are going to have 14 grams on top, and we'll have 100 grams per mole down. And 14 divided by 100 will give us 0.14 grams per mole. 0.14 molar mass, 0.14 mole, because we are calculating mole now, 0.14 mole. So that is the way to calculate number of mole of a substance. So which I believe you know that in the past. So let's look at this question as well. We are calculating the mass this time around. Remember, mole equals mass divided by molar mass. So we are calculating mass now, so we can make mass the subject of the formula, which is mole times molar mass. And what is the mole? The mole is 0.28. And what is the molar mass? We'll get that from the formula. So we have 9 atoms of carbon, and carbon is 12, so it's going to be 9 times 12. We have 8 atoms of hydrogen. Molar mass of hydrogen is 1. And then we have 4 atoms of oxygen, and molar mass of oxygen is 16. So eventually we are going to have 0.28 multiplied by the molar mass of acetylsalicylic acid. And what is that? The molar mass of acetylsalicylic acid is 180. And then when we do the multiplication, we are going to get 50.4 grams. So don't forget the unit, please. A right unit will give you the right answer.